So today's lesson is TED Ed, how far would you have to go to escape from gravity? And we're just doing a little preview here before we get into the lesson. So gravity is a property of, or you could say it's created by, what, right? What is gravity a property of, or what is gravity created by, right? It should be in your notes from last time. So take a look. Let me know through the chat. So Nate G has the answer here. Nate G, what's the answer?
Mass.
Mass. And then Juan, what was your answer?
Matter.
Matter. Okay. So those are both good answers, right? So we'll put them both in there in red. Okay. Matter / mass. Okay. All matter has mass. Okay. But either is a good way to think about this. All right. And so the formula for gravity, right? So the formula for the gravitational force between two objects. Okay, so the formula for the gravitational force between two objects is this one. F equals G m1 times m2 divided by r squared. Okay, so we have to remember a few things. Okay, G is a constant, so it never changes, right? M1 and M2 are the masses of the objects. Okay, and then R is the distance separating the objects. Okay, and it's really the distance separating their centers of mass, all right, to be specific. And then F, of course, is the force. Okay, so G never changes, right? So G doesn't, G's thing, right, is the thing about G is that it's a small constant. Okay, so it's small. Okay, G is small, right? G is a small constant. So the thing about G is, because G is small, okay, the masses have to be pretty large for the forces to be reasonable in size. All right. So the thing about G is it's small. So M1, M2 over R squared needs to be big for big F. Okay, that's the thing. That's the thing there. All right, and then M1 and M2, right? Okay, so as M1 times M2 increases, F increases because M1 and M2 are in the numerator of this formula, okay? Now R is in the denominator. So as R decreases, F increases, okay? By a power of 2, actually. So the distance between two objects is very important. All right. And we're going to look further at this relationship next time. Okay, next time. But we have one last little definition for the day, right? So escape velocity and we learned this last time, but I'm going to give it to you in a slightly different way than you've seen it before. The escape velocity is the velocity an object would need to have so that a particular or specific gravitational field, and I'll just simplify. So I'll abbreviate grav field. You know what I mean, gravitational. Could never pull the object back in. Okay. Could never pull the object back in. That's a good definition. All right. So we're going to get all this in your notes, and then we're going to head to our TED Ed lesson.